Hi, my name is Vashvi and we're going to be talking about candy crystals. In this video, we're going to be talking specifically about rock candy. Let's start with the basics. Each grain of sugar is made of a small crystal made of an orderly arrangement of molecules called sucrose. Sucrose is made up of glucose and fructose connected through dehydration or the removal of a water molecule. The sucrose molecules are arranged in a repeating pattern that extends in all three dimensions. When we add granulated sugar to water, some of the sucrose molecules start separating from one another because they are attracted to the water molecules through hydrogen bonding. Polar water molecules form multiple bonds with sucrose, therefore sucrose is highly soluble. First, the water molecules bind to the sucrose molecules, and then second, the water molecules pull the sucrose molecules away from the crystal and into the water. So, how much sucrose can dissolve? Only a certain amount of sugar can be dissolved in a solution at a certain volume and temperature. If we add more than that much sugar, no more of that sugar will dissolve and instead the sugar will just fall to the bottom. When this happens, the solution is said to be saturated. Looking at a microscopic level of sugar in water, we see the sugar crystal. In the beginning, when we add a little sugar to the water, most of the sucrose molecules are leaving the sugar crystals with the water molecules pulling them away, essentially dissolving. Some of the dissolved sucrose molecules are also crystallizing and rejoining the sugar crystal. At first, the rate of dissolving is much greater than the rate of crystallization. Once we add more sugar, the rate of dissolving decreases and the rate of crystallization increases. Eventually, the rate of dissolving equals the rate of crystallization, and this is when the solution is saturated. The number of molecules leaving the sugar crystal is equal to the number of molecules joining the sugar crystal. This means that the crystals and solution are in a dynamic equilibrium and the crystals do not change in size. So, how do we create the large crystals in rock candy? We use the power of heat. The dynamic equilibrium equation is as follows. We have heat and crystallized sugar on one side and sugar in the aqueous state on the other side. Let's talk about the recipe for rock candy. We combine 3 cups of sugar and 1 cup of water. We see that the solution is saturated at this point and all the sugar can't dissolve. Then we increase the temperature so the system is shifted away from equilibrium. The system acts to restore the equilibrium, so it wants to reduce the energy. The chemical breakup of bonds absorbs energy, so the rate of dissolving increases. All the sugar now can dissolve. Afterwards, we decrease the temperature so that the system needs to increase the energy. Forming bonds releases energy, so the aqueous sugar becomes crystallized. This leads to supersaturation. If we keep a stick in a cup while cooling the solution, over several days, the crystals will build up around the stick, creating rock candy. So, what about other candies? Most candies are made of syrup, but the variety stems from differences in the amount of time you let the crystals grow and the way the syrup is handled while it cools down. For rock candy, as we talked about before, the syrup is left for multiple days and large crystals are created. For fudge, the syrup is stirred constantly and a large amount of small crystals are formed. For gummy bears, the syrup is cooled down very quickly, so no crystals are formed. In a recipe, it's not only about the ingredients, but it's also about the way that these ingredients are combined. Thank you for watching.